Hello everyone, so today I'll be discussing question number 32 of set 2 GATE 2017. Consider the three prismatic beams with clamped supports P, Q and R as shown in the figures. So we have three prismatic beams, cantilever beams with different loadings. Given the modulus of elasticity E is 2.5 into 10 raised to the power 4 MPa and the moment of inertia I as 8 into 10 to the power 8 millimeter to the power 4, the correct comparison of the magnitudes of shear force S and the bending moment M developed at the support is. So for these three cantilever beams, we need to find the value of the bending moment and the shear force at the support. Then we have given 4 different options with the different values of bending moment and shear force. The comparison is given in all the 4 options and we need to choose the correct answer here. It's a 2-mark question. For these type of questions, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. Let's start with the solution of this problem. So in this problem, we will find the value of shear force and bending moment at the support location for these three beams, and then finally we will compare the value of shear force and bending moment and find the correct answer. So let us take up this structure, that is structure 1 first. So here let us draw the free body diagram for it in order to find the value of shear force and bending moment at the support location P. So here we have this applied load which is 80 Newton. So in order to balance it, we have 80 Newton upwards at the support location. The moment which will be generated due to this 80 Newton will be in this direction and the value will be 80 into 8, that is 640 Newton meter. So this is the free body diagram. From this we get the value of SP, that is the shear force at support location, as 80 Newton and the value of MP as 640 Newton meter. Now we will take up the next structure and similarly we will draw the free body diagram for this also. So here we have this uniformly distributed load which is having the magnitude as 20 Newton per meter. So we will draw the free body diagram for this beam also. So there is an upward load at the support location and the magnitude of this upward load will be 20 multiplied by 8, that is 160 Newton. We will also have the value moment here, the direction will be this, and the value or the magnitude of that moment will be 20 into 8 multiplied by the distance between this support and the center of this UDL. So the magnitude will be 20 multiplied by 8 multiplied by 4, that is 640 Newton meter. So we for this we have the value of SQ, that is the shear force as Q, as 160 Newton, and MQ, that is moment at Q, as 640 Newton meter. So for this structure also we have got the value of SQ and MQ. Now we'll proceed towards the last structure. For this we will again draw the free body diagram here. So this is the cantilever beam having the applied moment 640 Newton meter. So we'll draw the free body diagram for it. Since there is no applied load, either point load or the UDL, so there will be no upward or load or downward load here at the support, that is there would be no shear force. There is an applied moment only, so in order to balance this moment there will be another moment at the support here and the magnitude will be 640 Newton meter. So we can write that the R is 0 as there is no shear force, and MR is 640 Newton meter. For this also we got our answer. Now the last step is to compare these values. So we have 4 options here. In the first option it is written that SP is less than SQ is less than SR, which is wrong because SP and SQ, SP is less than SQ but it is not less than SR because SR is 0 here. Option number B is SP is equal to SQ is greater than SR, which is again wrong because SP is not equal to SQ. SP is 80 and SQ is 160. So this option number B is also wrong. Let's see option number C. Option C is SP is less than SQ, which is right, which is greater than SR. So SP is 80, SQ is 160 and SR is 0. So this part is right. Let's see the next part. MP equal to MQ equal to MR. So MP is 640, MQ is also equal to 640, MR is also equal to 640. So this option number C is correct because all these values are same. So we got the correct answer, that is option number C, which is this option.